Hello, in this short video I'm going to solve the following A+ level question. If y is 1 plus ln of x all over x minus x times ln of x, show that y prime equals to x squared y squared plus 1 all over 2x squared. Pause the video at this point and give it a try. Okay, so this function is given to us. We want to calculate its derivative and prove that this derivative is equal to this one. But be careful here because the right-hand side of the derivative is also related to the y itself. So it is not only in terms of x. So there is a twist in the problem. Okay, so let us see how we can work it out. So this is the standard one. Of course, it is clear that I wanted to calculate the derivative, and that's a quotient, so I use the quotient rule. Okay. So y prime becomes the derivative of the numerator. So let us write it patiently. Multiplied by the denominator itself minus the derivative of the denominator multiplied by the numerator itself divided by the denominator squared. This is just the standard quotient rule, yes? Okay, now let us calculate the primes. So the derivative of 1 is 0, derivative of ln of x is just simply 1 over x multiplied by this function itself, and if you don't mind, let me factor 1x out in anticipation that that x will cancel this x and makes algebra simpler. So I pull this x out, okay, and then here I have to differentiate this, which is 1. But differentiation x ln of x is a product rule, which tells me the derivative of the first one, which is 1 times ln of x, plus the first one itself multiplied by the derivative of the second one, which is 1 over x, but this is nothing except 1. So the derivative here is just 1 plus ln of x. Be careful, derivative here. But here, this I have a 1, I have a minus sign, and the derivative of this becomes 1 plus ln of x, but the minus sign goes for this one and that one. So this becomes minus ln of x minus 1. So this, what I have written here, is the derivative of that, and then multiplied by 1 plus ln of x. And in the denominator, if you don't mind, let me factor x out, and then totally to power 2. Let us simplify it one more step. This x and that x are cancelled, so I don't need any pair brackets, so it becomes 1 minus ln of x. Here, this minus 1 and 1 are gone. Minus minus becomes plus. Plus ln of x, I multiply it here. So it becomes plus ln of x plus ln of x times another ln of x, which is ln of x squared. And in the denominator, this is a product to power 2. So this becomes the first one squared times the second one squared. Yes, one more step. This minus ln of x and that ln of x gone. So this becomes 1 plus ln of x squared divided by x squared times 1 minus ln of x squared. This is indeed done. So the derivative is finished. But the twist in the problem is that we don't want to express the derivative in terms of x. We want to express it in terms of x and the original y function. One way is to start calculating the right-hand side by plugging this expression instead of y, do some algebra, and simplify it and write it in terms of x only, and compare that answer with that answer. Definitely it will work, and that is also a valid way of solving the problem. But let us try to make a twist to the problem. Let us say that the right-hand side is not given to us, and they say that, okay, this is your function, calculate the derivative and write it in terms of x and y. In other words, I want you to be able to discover this formula yourself rather than proving a priori given formula. So in that case, what I want to do is to go to my original function here. If I can eliminate ln of x because you see that there are no ln of x involved in that one. So if I can get rid of ln of x in favor of y, then definitely it should work if the problem is well designed. Okay, so what should I do? I go to the original function here and try to find ln of x in terms of y and x. What does it mean? It means that, let me go here, you multiply this expression by y and equate it to the numerator. So this becomes x times y minus xy ln of x equals to 1 plus ln of x. And now I move 1 to the left, so it becomes xy minus 1. I move this expression to the right, so it becomes xy ln of x plus ln of x. I copy and paste this one, but I factor ln of x out. Let me factor it out from the right hand side. And now from here, I can see that what ln of x is by dividing this expression by that expression. So ln of x is just simply xy minus 1 divided by xy plus 1. This is something I got for ln of x. And that's a good relation, because now if I take this with me and put it back in my derivative, at least you can immediately see that what you have in the final form is just x and y. And what you need is exactly just x and y. So hopefully this will work. Okay, let us do that. So the algebra, you have to be careful about doing the algebra right. So y prime is equal to, I have 1 there, but I have to raise this 1 to power 2 because this is ln of x squared, and a fraction to power 2 becomes the numerator to power 2 divided by denominator to power 2. And then I have x squared, and then I have 1 minus xy minus 1 xy plus 1 to the power of 2. But this is very simple, you know. For example, if I take the common denominator here in the numerator, it is xy plus 1 squared, and then this will go here, so this becomes xy plus 1 squared, and then plus xy minus 1 squared. This is the numerator. And the denominator is also simple, but let me keep this x squared there. I have to take the common denominator within this second power, so this becomes xy plus 1 to the power of 2, and this xy plus 1 goes here, minus the numerator, but the minus sign goes here and there, so it becomes minus xy plus 1. And more or less we are done, yes? So what I will do now, so let me write it in this form. First of all, this xy and that xy are gone, so this becomes 1 plus 1, 2 to the power of 2, 4. Yes, so I will have a 4 there, and then x squared here, so this becomes simply 4x squared. And the denominator to power 2 also becomes xy plus 1 to the power of 2. Okay, and I start expanding this. The first one squared, 2 times the first one times the second one. The second one squared, I expand this one, it becomes x squared, y squared, 2 times the first one times the second one squared, everything divided by xy plus 1 to the power of 2. And more or less we are done. You can see this one in the denominator cancel that one in the denominator. Here 2xy negative, 2xy positive are gone. This one and that one will be added, so it becomes 2x squared, y squared. This one and that one will be added, it becomes 2. And in the denominator, I have simply 4x squared. And I divide everything by 2, the numerator and denominator, or in other words, I rescale the fraction by a factor of 1/2. So this becomes x squared, y squared plus 1, and then this becomes 2x squared. Yes, and that is the y prime, which is actually demanded in this problem. So we have to calculate that that is y prime. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.